Record.
Hello, everybody. Glad that you are thinking about the Hunch washing machine projects. So to start off with, you can see that we've got this is a hardware patch. Just like astronauts have a mission patch for when they fly, a lot of hardware manufacturers will come up with a patch for their hardware. And so I've put together something just using clip art. But I could imagine that you might be able to come up with a better thing on your own if you have an idea for what your mission patch or your hardware patch might look like. I would be glad to see that. And I made this in the shape so that it would make a good patch for your shirt or whatever, but it could also make a good belt buckle. So that was some of the things I was thinking about when I came up with that. All right, Allie, if you could go to the next page for me. Okay, so in this presentation, this has got a lot more detail so that you can understand a little bit more about the environment that we're designing for, as well as the problems that are specific to the washing machine. So I'm not going to talk about every detail that's in here, but I'd like you to make sure that you read this very carefully, and don't be afraid to go on the internet and find more information about what the crew is doing currently. There are other examples besides just what's in here. Next slide, please. So this is some of the information about the clothing, how much clothing people are currently wearing, and some of the difficulties that we have with some of the clothes that we have up there already. Just, you know, how do we wash some of the things that, like a wristband that gets sweaty after running, or some of the harnesses and things like that. They do a little bit of cleaning with it, but it's also a complicated process when you don't have gravity to kind of pull away some of those droplets, or more if it's big blobs of water. Okay, next slide, please. So here we have had students in the past that have designed washing machines for us. However, designing a whole washing machine is really much more complicated. Although there were some really good ideas that were put forward by some of these students in the past, the overall idea was just too complicated for one small group of students to be able to wrap their head around it. There's so many difficulties with washing clothes, but also, this is a pretty complicated system. And so what we're trying to do with Hunch this year is, instead of one group of students or even one school trying to attack this problem, we're trying to break it out into pieces that are a lot more manageable. And by doing that, I think that we're coming up with a system that's more like a real engineering project, but it also gives you an opportunity to be able to work with more people trying to solve some of the very hard details, and overall together you'll be solving a very much bigger problem. Okay, all right. And I also think that there's a lot of creativity that is available, or that we're trying to give as much creativity breadth as we can for you, so that you can come up with the best ideas for your segment. Okay, next slide, please. So these are some of the requirements that we're trying to fit into. And as you go through here, there are things that you would want for your washing machine, right? You want to have some controls for it. You want to have you don't want to have to work on it every day. You want it to be easy to use. You don't want it to tear up your clothing. So these are things that you're going to need to think about, as well as we need it to fit into an express locker. How big can we allow these things to be? We have to get power from a specific place, right? But we also have to make sure that the dirty water that we've got, we can send it off to a place where it can get cleaned easily. Okay, so there's a lot of things that we have to think about, and as we design this, some of these requirements we might get more requirements, but these are definitely the first ones that we've got to consider while we're developing this. Okay, next slide, please. All right, so what's a double locker? And so here we're looking at the potable water dispenser, and that is the size of a double locker. And the idea is that just like a drawer in a file cabinet, the potable water dispenser can pull out from a drawer and be able to maintain it. And so on the left-hand side there, you're seeing this is the potable water dispenser, and it's inside of a double locker. On the right-hand side there, you're seeing the potable water dispenser has been slid out of it. It's on it is a drawer itself, and as it slides out, you can see the maintenance for the water filter that's on the inside. And so we're wanting to do something similar so that you would feed clothes in through the front, and it would go through the different rollers that we're going to talk about in just a minute. And then at the end, the clothing would come out. But if something gets caught up in there, if there's maintenance where we have to clean off a couple of components or whatever, all you would do is open up the drawer, be able to reach in and make that change, and then be able to slide it back in. And that way, the double locker itself is also acting as a way to be able to contain any water that might be trying to get out. Okay, next slide. All right, so on the left-hand side, you're seeing a double locker, and this is so that you can get an idea of what our spacing is. So you'll notice that it's, 21 inches tall, a little bit more than 21 inches tall, and 17 inches wide, and about 21 inches deep. And notice there that it also has little 45-degree angles that are 1.25 inches in that diagonal. And if you look, see, the picture on the right-hand side is an express rack. And if I take 2 of those single lockers and put them together, that is what a double locker looks like. Okay, so all of the ones in this particular express rack have single lockers, but if you would take 2 of those lockers and put them together, that would be a double locker. Okay, all right, next slide. All right, so here's the main idea. The idea is that we're going to start on the left-hand side. You're going to take a shirt, and we're all going to be trying to work with a medium-size polo shirt is what I'd like you to work with, just so that everybody's trying to clean the same shirt, the same article of clothing. And so you're going to have some rollers that kind of pull a shirt in, and part of my thought is that that roller would be able to inject the water into the shirt. Now, I'm not saying that that's exactly what's going to happen. You may come up with a better idea of how to pull that shirt in and get it wet. All right. However, it needs to be something as simple as possible. And then we need to let it soak for a little while. And then we need to pass it through some agitators. Now, agitation is one of those complicated things on orbit. A lot of times, if you are trying to agitate on orbit, well, when you're agitating on the ground, a lot of times you're using gravity to do that. And so my suggestion right now is to try to use some kind of a loose-spaced gears to be able to kind of agitate those clothes. Okay. From there, we're looking at, then we have to, you might want to let it sit there for a little while after agitation, and then we need to remove some of that dirty water. And to do that, I'm suggesting that we put it through some rollers and then some squeegees that would help take that off. So this is actually 2 steps right here, 2 different projects. There's the rollers themselves, and then there's the squeegees that are going to take the water off, and we'll talk about that more in just a little bit. And then the next step is to disinfect the clothes. So you've removed as much of the dirty water as you can, but now it would be good if you could kill off any bacteria so that it doesn't stink. And to do that, we're going to try some ultraviolet light and potentially use some titanium dioxide to help produce some hydroxyl ions. And we'll talk about that more in just a little bit too. And then the last step is we need to take that now slightly wet shirt that has been disinfected, and we need to spit it back out to the astronaut so that they can hang it up and let it dry. And so that last step is also pretty critical, just because we don't want it to get stuck. All right. Okay, next slide. All right, so here we're looking at, here are all of these different ideas in one place. So the one that I did not talk about in the diagram was the control system. So we're going to need a control system that's going to turn on my rollers. Well, actually, I have to let water into the system. So I'm going to open a valve to let water get into the soaking rollers and kind of to be able to get the shirt wet. And then I have to let it sit there for a little while. So that's what my control system is doing. And then my control system is going to turn on the agitation rollers, and it may take that shirt and go back and forth inside between those agitation rollers a couple of times, let it sit a little bit longer. And then my control system is going to turn on the rollers that remove the dirty water by way of some squeegees. And then it might also be asked to turn on a motor or something like that for removing that dirty water. Then it will push, those rollers will push it into the UV light and titanium oxide chamber. And then next it's going to, and it'll have to sit in there for a certain amount of time. And then it's going to turn on the rollers to remove it and send it out to the astronaut. Okay? All right. And part of your job is to make sure that you're keeping these items small, and also to understand what the other teams are doing so that you are feeding your idea into their idea. And that's where it's going to be good for you to be talking to some of these other teams, whether it's somebody in your school or even if it's somebody that's from another school. Okay, next slide. All right, so I've given a lot of, the next slides that I'm going to talk about, I am putting as much in there to help you go in the same direction, but I do not want to stifle your creativity. So I want you to be thinking about, this is what I've thought, and I've got some requirements and restrictions that we have to be aware of, but you may come up with a better idea as well. So don't think that I'm pushing you in only one direction. Okay, next slide. All right, so now I've put a lot of detail in here to talk about how to get clothes soaked. One of the things that you have to consider is that if I spray this water onto shirts without gravity, a lot of that would bounce off and just go out somewhere else. So spraying it on is not really an option. In some ways, let's see, if I just put water onto the surface, it might just sit on top and it may not get soaked in. So really we're needing to come up with some way to be able to kind of push the water a little bit into it. Once the water is into the cloth, I expect that there will be a lot of capillary action that will pull that water throughout. So we don't have to hit every centimeter or every millimeter of that shirt to get it wet. That water will continue out through the rest of it on its own, just by way of capillary action. The surface tension of the water will help hold it onto the shirt, but the capillary action is what should pull it into the rest of the cloth. Okay. Now, one of the difficulties is that if I do it the way I'm suggesting here with these rollers and some like injection things, the difficulty is that I don't want to be squirting water out of the top of the rollers. I only want the water to be getting onto the shirt. So that's one of the complications that makes this one very difficult. Okay, how do you activate only the nozzles that are in contact with the shirt? Okay, so that could be very difficult. Next slide, please. Now, so the agitation, the way I was envisioning it was having these big, kind of big tooth gears that could pull the shirt in, pull the shirt one way, and then push it back the other way, where these gears would be kind of pushing the shirt into those things, and then being able to uh, kind of agitate the water enough that maybe you're loosening up if there's food items on there, or just trying to help massage that water around into the areas that might be dirty. So this is also a fairly complicated project, just because nobody's really done this before. This is a new venture of how do you agitate a shirt without gravity. Okay, next slide. Wow. Okay, so this is a complicated one. So here I'm suggesting again some rollers, and the idea is that as these rollers pull the shirt in that's already wet, that I want to remove that water. In 1G, that water would just drip off of the bottom and fall down onto the ground or whatever, or back into a bucket. Well, that's not really what's going to happen in 0G. And if you watch that, there's a link here that shows one of our astronauts wringing out a shirt, or wringing out a washcloth, and you'll see it behaves very different. And so my suggestion is that we have some rollers that help squeeze that shirt dry, but having some squeegees that will help kind of keep that water from coming around all the way to the other side and just re-wetting the shirt. And so part of the project is, or this part of the project is coming up with rollers that will be able to squeeze the shirt the appropriate amount, and then also being able to hold on to the squeegees that are for the next step. Okay, so next slide. So here, this is one of the two squeegees, and the idea is that our, oh, it looks like I made that roller go the wrong direction. I'll have to look at that. But so as the water is squeezed off of the shirt, it will go onto the squeegee, which will keep it from rolling around to the other side, and then getting sucked up by what I'm calling a slurper straw. And so that slurper straw is going to have holes that will allow it to suck in the water, but this is dirty water, so there might be like food particles or something like that. So we have to choose a size that's going to be able to handle some of those food particles that might come off, and then get pulled through that straw and into a separator that'll be able to send that water out to the cleaning system. Now, the separate, as the water is coming off, there's going to be some air bubbles and there's going to be water. And as that water is drawn off, it's going to be pulling in some of those air bubbles that in zero gravity could cause problems. And so the pump that pulls the water off of this straw is going to have to be probably a centrifugal pump that will be able to handle removing some of those some of those air bubbles. Now, that's not something I want you to be worried about, because that's actually really complicated. That's something I expect that we'll have to do here at NASA. We will come up with a pump that'll do that. But being aware of how that works may help you understand what kind of a straw you need and what kind of squeegee we need as well. Okay, so I've given a little bit of definition on that, and we'll talk some more on it. I will probably have to put some more information on the web page for that. Okay. All right. Next slide, please. All right. So here, this is one of the more scientifically interesting components. And so here we need a chamber that's going to have ultraviolet lights in it. and also some titanium dioxide. Now, titanium dioxide is pretty much just a sand. It's a very special sand that is made out of just titanium and oxygen. And my suggestion, let's see. So you might want to read up a little bit on this. The idea is that when titanium dioxide is exposed to ultraviolet light and water, that the water will be disassociated by way of the titanium dioxide being a catalyst for breaking it apart into hydrogen and hydroxyl ions. And the idea is that those hydroxyl ions will help, it'll attract itself to germ cells, break those up and turn them into water and carbon dioxide. And that means that we're killing off bacteria as well as removing some of the smells that would be in that shirt. So I looked up some titanium dioxide. You can get some for something on the order of somewhere between $2 and $10, depending on how much you want. So it's not something that's really difficult. Okay. Now, in this particular one, we do not want to try to use ultraviolet lights. The UV lights that we will be needing could be hazardous to you. They're also very expensive. So in this particular case, for the sample that we're trying to demonstrate with, all you need to use are very cheap and easy to find LEDs. And so we're just trying to demonstrate how this shirt would be cleaned. We don't have to actually do the cleaning. And in the same way, if you can't find titanium dioxide, which it's just on the internet, you can use something, another kind of a sand-like material. But I think titanium dioxide is pretty easy to get hold of. Okay. Next slide. All right. So then, after it comes out of the chamber for killing off the bacteria, then we're going to be just sending it out and trying to dry it out by way of hanging it up. Now, although this sounds like just another set of rollers, this is also a set of rollers that its job is not necessarily to remove any more water, but just to send the clothing out. So they could be just kind of flat rollers, but you might want to have a little bit of grip on them, just so that as the clothing comes in there, it's able to push it all the way out. We don't want it to get, we don't want it to bind up inside. We want it to kind of get pulled out pretty easily. Okay. Now, those are not my kids, although I wish I had. That is quite the funny picture. I just found it on the internet. But our astronauts are not going to get anywhere near that dirty. All right. Next slide, please. All right. On the control systems. So this is something that is this is very complicated and difficult, because every pair of every kind of clothing that you're going to go in there might be a little bit different in size and dimensions and things like that. So one of the things I was considering was, if I were to have a shirt and then clip something to that shirt that is the same every time, I was thinking of, like, you know, something the size of maybe maybe larger than a dollar bill or whatever, made out of a semi-rigid material. And over on the right-hand side, top corner there, you can see that there's kind of a, I think we call it alpha glass, or it might be a Teflon-coated fiberglass. But the idea is we need some kind of a leader, something that I clip it to the clothing, and when it goes into the machine is geared specifically for that type of material, so it's easy to pull it all the way through the system. And part of what I was also thinking was that you might be able to put some information on that leader that tells, this is a shirt, this is a pair of pants, this is a pair of shorts, and that would help the system know how much water do I need to put onto this item. So obviously a pair of long pants is going to need more water than a pair of running shorts. And so if I had some information on there, I could have a barcode reader that's so that the Raspberry Pi or Arduino would understand, I need to put more water into this long pair of pants. And I might only need 75 milliliters of water for this pair of running shorts. And so it would know how much time to send water into it. I might also need to know this pair of pants might need extra time in the UV lights to kill off that bacteria just because it's larger material, okay? And so this control system is going to be very critical to not only running each one of these components, but also timing it. And it also might need to have some information about, there's a jam and you need to pull this, you need to open up the system and be able to maybe jog one of the motors so that I can pull that shirt out without ripping it or without it getting damaged, as well as to make sure that I can turn off those lights so that the person doesn't get a sunburn from the UV lights and things like that. It would be helpful if there was some kind of a display screen that says what part of the process the system is in. So it might start off as soaking. Your shirt is soaking right now. Your shirt is in the rollers to remove the water, and there might be another indication that UV lights are on, do not open, and things like that. And so there needs to be some kind of capability to tell us how the process is going, okay? And I think that because I'm asking for a screen, it probably pushes you more towards a Raspberry Pi. I don't think Arduino has as much capability there, okay? Let's see. All right. I think that's it for this one, okay? Next slide. Now, this one is not required for you as much as it's to give you an idea of some of the things that we're looking at. So you'll notice that I have to have a place on the front of this, the front of this device so that I've got power that's going to connect to the front. I'm going to have a hose that's going to connect up for the dirty water and a hose for the clean water, okay? Now, the water is going to come in at room temperature, somewhere around about 71 degrees or so. And it's going to have iodine in it. And that's in the same way that your water coming in at home probably has some chlorine in it, and that just helps prevent bacteria from growing in it. The same thing is with the iodine. If you go at the bottom, I was kind of envisioning that the clothes would go into the bottom and then come out at the top, but that's not a requirement. That's just a thought. There needs to be a switch so that I can turn the whole thing off, and it needs to have an LED to indicate whether it's on or off. I'm looking for an information screen. It'll tell me something about what's going on. It would be wise to have some kind of a USB connection so that if something is going wrong, we could hook up a computer and be able to reprogram it or something like that as well. And then there might be a couple of switches and buttons. You might have like a jog button. You might have so that you can advance some motors, or it might be a switch so that you can turn on the lights at a particular time for some reason. Maybe you're doing some diagnosing of a problem. So I'm just trying to give some room for things that we might need in the future. Okay, next slide. So I've mentioned before I'd like us to be working with a medium-sized polo shirt that gives everybody the same kind of thing to be testing with, and something that's easy for everybody to find. Okay, someday we will have to make this thing so that we can do pants and socks and all kinds of things, but initially let's just start with one thing to try out. Okay, next slide. All right, and this is my analogy of what we're trying to do. Obviously, it would be better if we wanted to put soap in here. It could be better if we had hot water. Right now, we're just trying to do a very simple washing machine. You can imagine if you wore a shirt for a week or two and then wanted to wash it off, a simple way to do is to take it into the sink, kind of wash it around in that water, wring it out, and then hang it up to dry, and it would get, I don't know, let's pretend that that gets 80 to 85% of the dirt out of there. Now it's much more interesting to wear that than what you had before. And so, um, so this is a very simplistic type of washing. If I um, if I added water, or excuse me, if I added soap to this, it means that I'd be having to remove that soap from the water that I'm trying to clean. So I'm trying to do as little of an impact on the water cleaning system as what I can, but still be able to give the crew a cleaner shirt. Okay, so this is not intended to be the perfect system for cleaning clothes. It's just intended to be the first system that we could test on orbit that would be able to handle it. Okay, next slide. Is that the end? All right. Okay, so we've hopefully you guys are excited. Hopefully you see that there are some new ideas to be working with, and I look forward to all of your ideas. Thank you very much.